Hi, I'm Bruce. Welcome to the Baptronics Colorado Mountain Shop. And we've got our HP5381A here. This is the last of my three 5381s that I was fixing up for sale. And we had it up this week already once, but somebody contacted me and pointed out that the decimal point on the megahertz position was not working. So I totally missed it, and I pulled the ad off of eBay, and I went ahead and replaced the segment. It's the sixth segment the decimal point is on, and it wasn't working on the prior. But as you see now, it is. And once again, we've got a beautiful faceplate. Looks really quite new. You'll notice in the bottom here that we have a label that's stuck over top of the original name. That's because this faceplate actually came off of a 5382, which is a 225 megahertz unit, and this is a 5381, so I labeled it appropriately, but utilized the faceplate because it's a beauty. Looks new. Everything else about the faceplate matches. And I've replaced now two segments of the LEDs with LEDs removed from the 5382, my sacrificial unit. And right now we are looking at a 10 megahertz signal coming from my master oscillator, that silver faced unit with that tube sticking out of it. That's actually a 10 megahertz filter. And that master oscillator was calibrated with a rubidium unit that's it's setting on top of. It's that kind of a grayish green unit. And I've utilized it to provide the 10 megahertz signal here, and we calibrated to that. So right now we read 10 million, but we want to see just how accurate it is. So we're going to go to the kilohertz range, and what that does is shoves the one off an over range, but it gives us a view of what's down below. So here in the kilohertz area, then we see if it's kilohertz above, then it must be hundreds, tens, and ones down below. So we're getting a count of either plus or minus 1. And then we're going to go to the 10-second unit, or range, excuse me, gate time. And we want to get a view here of just where we are. And I think, okay, here we are. We're a tenth of a hertz over. 1/10 of a hertz over 10 megahertz. Pretty small error. Now, and there actually it's not even a tenth of a hertz. So it just went to 0. So we're somewhere between a tenth and 0. This calibration is only going to be good if your room is at the temperature this room is, which is 68 degrees. And the unit's been allowed to warm up, which this one has now. It's been warming up for 3-4 hours. And but under those circumstances, it should come back as long as nobody fools with the calibration again, at least for a while. So we've got a good calibrated unit. We're reading our frequency just fine. We're going to run it through its paces in a moment, but first let's just take a good look at it again. It's been repainted with a real nice sage green. Looks great on this cast metal cabinet. That's one thing about the HPs. You try and buy a cabinet like this, you're going to be really shocked. Unless you buy it surplus. If you try to buy it new, you'd be looking at $100 or more if you could get it. You see we have a couple of rubber feet on the bottom, replacing the old Bakelite bar that used to be there. And then we'll take a look at the rear. It's a serial number 1404A02059. We have an external oscillator. Switched, you get either external or internal. And you got the input there. If you were running off of a bench oscillator, which is always a great idea, especially if you can run your signal generator and your frequency counter off of a same master oscillator, the pair of them are going to work in sync with each other, and it'd be a beautiful thing. But if you're going to run them separately, which this is capable of, then that's fine too. Okay, so let's, once again, we're going to go ahead and check the sensitivity spec on this unit and see if it still meets spec. According to the spec sheet, we're good from 10 Hertz to 80 megahertz. From 10 to 20 megahertz, we require 25 millivolts RMS, minimum. From 20 megahertz to 80 megahertz, it doubles. It goes to 50 millivolts RMS. My previous video, I failed to make the conversion from RMS to peak when I was looking at my scope. And the result was my scope was giving us a value which was accurate for what it was for sensitivity. But when we were relating it to the 25 millivolt, we were really sliding the unit. The unit was performing much better because when you go to convert RMS to peak, you divide by 0.7071, and you're going to wind up 25 becomes like 32, I think, or 35. We'll check that in a few moments. And then 50 becomes like 70. So if I was performing well to 25, I was performing fantastic to 32. That's what I'm trying to get across. But we're going to go ahead and check it again. So bear with me and we'll hook it up. All right, we have a 20 megahertz signal coming in on the unit right now, and we're reading 20. 20 megahertz is coming from the PTS 500 right there. But I fed the output of the PTS into this dual attenuator with 10th dB and 1 dB steps up to 11 dB I can get. And I've got the attenuator set to maximum attenuation. And what I'm going to do is we have the 20 megahertz reading right now, so we've got enough signal to do it. What I'm going to do is I'm going to change the gain on the PTS output to the point to where we see that 20 megahertz fall out and we are not able to read it. All right, there we fell out, we're not reading it. So now what I'm going to do is I'm going to start with the 10th dB unit, and I'm going to start backing down on my attenuation, and the signal will become stronger every time I do it. And I'm going to search for the point to where that 20 megahertz kicks in. Starting to see some activity. All right, we're going to go down a dB, and we're going to raise the 10th up again. Okay, now we're seeing it. This is the point where we're just beginning to get it, right there. There's our 20 megahertz. So this is going to be our sensitivity for this 20 megahertz reading. So let's read what the output is at this point. All right. I'm going to connect to my scope. You see I have a 50 ohm load on here, so I am loaded as if I was connected to the meter. And we can see the signal if I turn it up there. But let's go ahead and kill the sweep and just reduce it to an amplitude. I'm on 5 millivolts per division right now, and what I'm seeing is 5, 10, 11, 12, but somewhere between 12 and 13 millivolts. I'm going to say 12. So 12 to 13 millivolts is the minimum signal required on this unit at 20 megahertz. Now, it's rated at 25 millivolts RMS to meet spec. So we have exceeded spec because 25 millivolts RMS is about 35 millivolts peak. We can check that. Okay. So let's say 25. And then we want 0.7071. What does it say? Equal 25 divided by that. And for a sinusoid, that should be right. We get 35.35 millivolts. So 25 becomes 35. So if we were anything under 35, then we've exceeded our spec. And we're running 12 to 13. About 1/3 of that. So fantastic. Now, it says that we're from 20 up until 80, we're going to require 50 millivolts RMS. And 50 is going to be equal to 70 peak. If 25 was equal to 35 peak, then 50 RMS is equal to 70 peak. So let's go ahead now, and we're going to change our frequency to 80 megahertz. Right, that's 80. And go ahead and turn our attenuator back to maximum. And then we're going to hook up our lead to the HP. And let's go ahead and turn up our signal till we get 80. Okay, now we're seeing 80, not a problem. I'm going to back off now. Okay, right to where it just fails. So it's failing right in there. It's not reading 80, it's reading somewhere in the low 60s, and it's just not able to count it. So now I'm going to go to the 10th dB attenuator switch, and I'm going to start reducing attenuation, increasing the signal strength until we see the 80 come into view nice and solid. That's the first step. Second step. Third. 0.4, 0.5, 0.6, 0.7, 0.8. Right there. Just getting 80 right there. If I went one more, we'd be a solid 80. So I'll do that. Let's go ahead and see what we get. Okay. Well, we're considerably larger than we were, but let's go to 10 millivolts per division. And let's check our calibration here. Looks good. Okay. And what I see is 10, 20, 30, about 31, 32, I guess. 32 millivolts peak. And at 80, we're supposed to be under 70 millivolts peak. So, geez, we're 50% better than that. About half of that. Fantastic. So, at 80 megahertz, we've exceeded the spec. At 20 megahertz, we've exceeded the spec. Now, if we just go down to the low end at 10 hertz, and we're able to resolve 10 hertz with less than 35 millivolts peak, then we got that too. But I can't do that with this PTS 500, since the lowest frequency I can work with on this thing's about 100 kilohertz. So we're gonna leave it, and we're going to switch over to this HP. So give me a minute and I'll... Okay, we are now connected to this HP5381A. It's a low frequency synthesizer. Does well frequencies below 2 megahertz, right on down to just about 0 hertz. We're feeding in a 10 hertz signal, and what we want to do now is to increase our attenuation to the point that we lose that 10 hertz signal. So let's do that. Increasing. Right about there. Okay. So now I'm going to back off on my attenuation at 1/10 of a dB a step and see if we can figure out at what point we come in. Right about there, we're coming in. So let's take a measurement on that and see what we got. Okay. I'm going to go to 5 millivolts per division. And what I'm seeing, pardon me, 5, 10, 15, 16, 17. About 17 millivolts peak. And I was able to get a 10 hertz signal on here. And we said we needed to be under 32 peak. So once again, we're about half of that in terms of required signal strength. So we beat that spec all to heck. And just for kicks, let's take this down to 5 hertz. It's not rated at 5 hertz, but let's do it. Alright, I want to increase my signal to the point that I'm able to get 5 hertz, so there it is. If I go to the 10-second average, we should see that pop. This should read 5.0. Yep, there it is. Let's see what we're at. Okay. Well, I'm requiring more signal than I did with the 10 hertz. So let me go to the 10 millivolt per division range, and I'm reading 10, 20, not quite 30. I'm reading about 28 millivolts peak at 5 hertz. And at 10 hertz, I was supposed to be able to read this with 35. So if I'm under 35, I'm doing well, and I'm not even supposed to reach 5 hertz. So 10, 28, 28 to, I'm under 35, so we're beating the 35 by 7 millivolts. So there you have it. We've met our spec. The unit is a handsome unit. It looks well. It's performing well. We've corrected errors that were noticed. Thank you, Dave, for pointing it out to me. I wouldn't want to disappoint anybody. There we go. There we go. As usual, I don't know who the customer is that's going to buy this. They may be just starting out, and if they are, I don't want them to not be able to utilize this thing right out of the box. So I'm throwing in a set of coaxial gator clip leads, so you can have a way of connecting. We've got the HP5381 user manual and service manual on the diskette here. It's a CD. And we've got a new power cord. It'll all come with the unit. I'll package the unit very well so that it can make the trip safely. So thank you for listening. Happy bidding, and see you next time.